Hello everyone, and in today's video we're going to troubleshoot this tiny alarm clock. And I say troubleshoot because, well, this is a tiny, it's one of those quartz movements, and normally I would just replace it because they cost a few euros, and my time is valuable, so it's cheaper for the client to just replace them because they're a few euros. But this movement, since it's an alarm clock movement and it's a Japanese alarm clock movement, it's a bit more expensive. It still would not be that expensive of a replacement, but I was thinking let's just take a look at it. So this is a Japanese movement from a company. I googled it online. We'll put the company on the screen. Couldn't find much about it. However, I see there's exact same movements now, and with exact I really meaning one-to-one copies, sold by Psycho. So I assume that original brand got somehow absorbed into Psycho. So yeah, this was an alarm clock made by Habitat. You can kind of see it on the dial there. Habitat is no longer in business. At least not in Belgium. Maybe in other countries it's still around. I don't know. But yeah, alarm clock has some sentimental value. That's why they wanted to move for repair. So let's get into troubleshooting. So at first let's do just like a visual inspection, so we can see because it doesn't tick at all. So are there any you can see watch hands are fine, they're not touching each other. They also let them turn, so that's fine. So that's the one to set the alarm. Now let's pull the other one out. Oh, and there we have the alarm. So we know that's working. Now let's put this switch down so we don't hear the alarm again. So yeah, there's no mechanical blockage or anything. So next suspicion, the battery. Battery's not great quality, but yeah, if it's fresh it will probably do. But let's quickly get the multimeter out to check the battery. I'm going to put the backlight on so you can see. So yeah, let's quickly check the voltage on the battery. No need to remove it. So we have 1.6, which is, yeah, that's above what it should be, so that's fine. This also means that this battery is fresh. So why do I test this inside of why do I test the battery inside of the movement? Well, first of all, if you pull it out, that's the voltage without load on it. So if it's like something that's drawing a lot of current inside of the movement, I wouldn't know. So basically this is two checks in one. Check the voltage of the battery, and I also know that it's not getting loaded too much. So yeah, we know battery is fine. Next thing we're going to do is we're going to check for pulses. So how do we do that? Well, we're going to get the multimeter again. We're going to put it on current microamps. We're going to put in the right slot. Now I'm going to put the backlight back on so you can see. And now I'm going to get the battery out and then just bridge the contacts. Make sure we're still touching. So we're getting a current and we're seeing a bit of fluctuation, but we are seeing no pulses at all. And I will show it with another movement that I know is good working, what those pulses mean. I did the same with this movement. Can make good contact. As you can see, it goes up and down. So that's basically, you can see every time the current is high, that's one pulse. So yeah, we're not seeing that. We're seeing a little small fluctuation, which might be just that it's trying to, which probably means that like the coil is like disconnected or something like that. Let me quickly see. So to get the movement out, there's 2 screws here, and then probably going to do that. Yeah, let's just do that. Because I need to pry the glass out. Let's see, can I? There we go. So now I can carefully remove the watch hands. So one removed. Two removed. 3 removed. And this one is going to be 3-1. And there we go. We got that one off. Now, just need to undo those screws at the back. There we go. And now, I presume we pry this open now. They're not always easy to open. Because like you gotta like lift this little lip here, and then we got it out. Now I'm gonna do the same on this side. There we go. Now you got a spring flying out. It's not a good start. Okay, so what do we have here? we have apparently that one has to come off somehow. Yes. Okay. So now let's get all the gears out. That's the lever that turns the alarm clock part on and off. Now, we have here the coil, and it seems like they're just relying on pressure to get the coil going, like to make contact with the coil. So that might be where our problem is. Okay. Let me quickly grab some supplies and we'll see if that's the problem or not. So and then I was thinking, like, let's just quickly check if the coil's still good. Normally it should be good. Like, it hasn't been opened unless I really damaged it. Or what sometimes can happen is like the installation fails over time. Like, this is a 30-year-old alarm clock, so it could be. So yeah, let's quickly check. Let's try to hit. So we get 290 ohms, which is within range. I don't know what exactly it should be for this kind of alarm clock, or like quartz movement in general. But that's about the range most of them are. So yeah, now let's hook it up. So I'm going to get like a permanent 1.5 volt source on here, and then I'm going to try to jiggle it around. And if that doesn't work, then it's probably the IC that isn't making pulses. So yeah, that's going to be game over. But yeah, let's check that. So I've now hooked up to like a permanent 1.5 volt supply. Now let's see if I press on here, try to make good contact with it. No, we're not getting any difference. Let's see if there's anything. Crystal's still well soldered. So yeah, it's probably just the big IC, the IC here, the big blob there. Crystal's going to be fine. Soldering is also fine. That one cap is not suspicious. So yeah, it's going to become a new movement. But yeah, that was it for the troubleshooting. There was just one more thing I wanted to show. Might have to show that under a microscope, we'll see. But yeah, I'm just going to replace it. So yeah, let's see. I'm going to try out, because I want to show you how basically the alarm clock part works. Because, yeah, it's fairly easy, and it's pretty comparable to like how a mechanical alarm clock does it. That's why I thought it was interesting. So yeah, up to that. So here we are with the microscope. So as you can see, I have two of the alarm clock hands under the microscope, and Yeah, so as you can see, they both have like specific cutouts. So the way it basically works is they only go together one way, which is like the alignment here. This one, the gray one, is your like your alarm clock hand. So this is basically you set this at the time you want your alarm clock to go off. And the other one, the small black one, is your hour hand. So when those match, let me show how that looks. When they match like this, or maybe a bit better. See when no, and I stay together. Let out of frame. Yes, so when they match like this, that means that like your hour hand is at the hour you set your alarm clock for. So that means that it's time to wake up, or whatever you set your alarm clock for. So what happens on the inside? Well, let me show you. You have this, which is a contact, like an electric contact, but also a spring. So basically, it takes your positive from the circuit board where everything was on, and then it puts it on the buzzer, like the piezo buzzer on the backside, and you saw a little switch. Well, that little switch just like it enables this contact basically. So so basically there are like two switches in one. One is switched by like the little switch at the back, and the other one is switched by this one. So this one can go up. It lets it come into contact with the piezo at the back, and that completes the circuit, and well, the piezo does its thing. So that's basically how the alarm clock part works on a quartz alarm clock like this. Like I said, it's pretty similar to how a standard mechanical alarm clock works. You also have like the two, like your index wheel that needs to align, and then something can jump up. Well, basically this is just the same. Just the same principle. It's an electronic alarm, but the switch is still mechanical. And that's how, well, this one is a 30-year-old movement, but yeah, they still do it the same way on today's movements. Like on most of them, some use another way, like some use like a more normal mechanical contact, and they use more like a switch, but yeah, this one does not. So yeah, what's going to happen to the clock? Well, to the alarm clock? Well, I'm going to just order a new movement, place it back into the case, and that is it. There's no point of me putting any more time into looking at it, because well, clearly there's something going on that's beyond my ability to repair. So yeah, I'm not going to show that in a video. Me swapping a movement is not interesting. So yeah, that's it for this video. I hope you liked it, and see you in the next one. Bye bye.